Lesson 3, Unit 7, homework. Here we go. We got two lines that are intersecting at this point here. And our job is to find the value of B and C. All right. So let's start with B because that is the best place to start with this problem. If you look at angle B and the angle that's 42 degrees, we learned that they're opposite of the intersection. And so therefore they are vertical, and vertical angles are equivalent. So because they are vertical, B equals 42 degrees. All right. Because of vertical angles. And there's our reasoning. All right. And then the other thing that we have to do here is we have to find C. So how are we going to find C if we don't know what its vertical angle is? Well, whenever you make intersecting lines, it doesn't just have a vertical angle relationship. We also noticed that whenever you do that, since they're on a line like this, then the two angles that are side by side or adjacent to each other, those two angles have a sum of 180. So what we know here is that C, whatever it is, plus 42 will add up to 180 degrees. We know that that's true because it's on a straight line. It's supplementary. Okay, they are supplementary. I'm going to write that on here. I can't say that phrasing enough, is that supplementary and complementary phrasing in vertical angles. So supplementary means this. So to find C, we just have to find 180 and 42's difference. So if this was 40, that would be really easy. It would just be 140. But we got to take 2 away because it's 42. So that would be 138. So C is equal to 138. And so is its vertical on the opposite side. We could actually answer that too. So those are our answers for B and C on number 1. On number 2, we have a triangle, and it's a right triangle. And angles R and S are complementary. This means they have a sum of 90. This is vocabulary you've got to commit to memory. Complementary 90, supplementary 180. Complementaries are corners, 90 degrees. Supplementaries are straight lines, straight angles, 180 degrees. And so we got to find S. So if they're complementary and they add up to 90, that means that R plus S equals 90. We can look at the picture and see that R is equal to 62 degrees. And so our job is to find out how many degrees S is, similar to what we did with the 180, but this time our total is 90. So to find S degrees, we are going to subtract 90 minus 62. Well, counting up, 8 would get me to 70, and 20 more would get me from 70 to 90. So 28 is the difference, and that is the number of degrees that you would have here. And that's number 2. All right, moving on to number 3. If you have two angles that are both vertical and supplementary, so that means that they equal each other, and they have a sum of 180 degrees. Can we determine the angles? Well, I've got to have a number, so A, and it has to equal itself, so there has to be two of them added together to have a sum of 180. Well, we can determine the angles, yes, because this is pretty easy to solve. 2a's equaling 180 means that each of them is 90 degrees. So, yes, on the first one, and there's our proof. Is it possible to be both vertical and complementary? Okay, vertical means equal again. So vertical, let's call them B this time. B plus B. They're vertical, they're equal to each other, but they are complementary this time. So they have a sum of 90 instead of 180. Is that possible? Well, 2B's equaling 90. We divide the 90 by 2. Yeah, each angle would just have to be 45, split into 2. Yes, that could happen. If so, can you determine the angles? Explain how you know. All right, so it looks like we've determined the angles. And I think our explanation is in our algebraic shown work there. So I'm not even going to worry about a sentence. I'm just going to show that work. I think that's enough. Number 4 is a throwback to last unit, factoring out expressions. Most of you guys are really good at doing this. So we'll just do the examples really quick. Part A, what number goes into both 15A and 13A? Well, there's not a number, but there is a variable that goes into both of them, and that is A. You can factor out the A since 13 is prime, and nothing will go into 15 that also goes into 13. You can just factor out the A and be left with that. Easy peasy. All right, part B. Negative 6x minus 18y. You do not have like variables that you can factor out like you did on the first one. So we can't pull out an x and a y here. But we do have 6 and 18, which share a common factor of 6. So we can actually factor out the 6 in this problem. And if you divide both parts by 6, negative 6x divided by 6 is going to leave you with a negative x. The 6 just kind of gets pulled out of there. And minus, if you divide 18y by 6, 18 divided by 6 leaves you with 3y's. So that one turns out to be that. And then the last one, part C. All right. You've got numbers and letters that can be factored out of this one. Let's start with the letters. What letter do they both have in common? They both have an A in them. So you can factor out the A. So the A's out in parentheses. And then looking at 36 and 54, the first number that comes to mind for me is 9. But maybe there's a bigger number, 12. No, 12 won't go into 54. Maybe 18. 18 times 3, I think, is 54. So we could factor out 18a, and that would leave us with 36 divided by 18a. 18 will go into 36 twice. And since the A is already out, the B, and the C need to remain. And then 18, as I mentioned, goes into 54 3 times. So you're going to have a 3. And since the A's been factored out, the D remains. So there you go. There's 3 factored problems, and that's page 2 of your homework.